Okay, let's take a look at this problem. Linear programming problem. We've got medical kits that are 1 cubic foot and weigh 10 pounds, and we've got bottles of water or containers of water that are also 1 cubic foot and weigh 20 pounds. And we've got a plane that will only carry 80,000 pounds in total and will only carry 6,000 cubic feet. Our objective function comes from this sentence right here. Each medical kit will aid 6 people, and each container of water will serve 10 people. So the number of victims that can be aided will be determined by 6x plus 10y, because each medical kit will aid 6 people, 6 times x, and each bottle of water, y, will aid 10 people. So for example, if we send 1,000 of each, we'd have 6,000 medical kits, and we would have 10,000 containers of water. So we could aid 16,000 people with that combination of kits, 1,000 medicals and 1,000 containers of water. But we might be able to come up with something different numbers to give us more victims to be aided. So this is our objective function. These are the constraints. We're not going to send a negative number of kits or containers of water, so x must be greater than or equal to 0, and y must be greater than or equal to 0. The plane will only hold 6,000 cubic feet of volume. Each medical kit contains 1 cubic feet, and each container of water consumes 1 cubic foot. So if you picture these with 1's in front of them, 1x plus 1y is the number of cubic feet that are going to be consumed by that number of each. And that total has to be less than or equal to 6,000, because that's what the plane will hold. And for the containers of water, the plane can carry only, for the pounds that the plane can only hold 80,000 pounds. So each medical kit consumes 10 pounds. That's 10 times x. Plus 20 times y, the number of pounds for a container of water. That has to be less than or equal to 80,000. Otherwise, the plane cannot hold those kits. So there's our constraints. If I go to board 2, what we're going to do is graph the constraints. I just put the first quadrant up here because x has to be greater than 0, y has to be greater than or equal to 0. The border for x plus y is less than or equal to 60,000 can be gotten by solving for y, and we have a y-intercept of 6,000. By the way, I have each square counting for 500, so this is the point 1, 2, 3, 4, 5, 6. This is the point 6,000 right here, 0, 6,000. So that's the y-intercept for that first constraint. It has a slope of -1, so I'm going over 1, down 1, over 1, down 1. And by the way, when y is 0, x is 6,000, so that's this point right here. And I draw in that constraint in the first quadrant. The side of the red line to shade in is, of course, under that line, because if you pick the point 0, 0, it gives you a true statement. For the second border, I can solve for y, and I end up with this. And so the y-intercept is 4,000. The slope is -1/2, so over 2, down 1, over 2, down 1. And by the way, when y is 0, x is 8,000. So this is the point 8,000 out here. And under that green line would be this. And so this black region right here is the area that they have in common. This is like the region that we're going to use to maximize our objective function. And by the way, how did I find this point right here? I solved this system of equations, this one, and I used this one. And I used the substitution method. So I substituted negative x plus 6,000 in for this y, and I got this equation. I multiplied every term by 2. I added 2x to this side, subtracted 8,000 from this side. I got x equals 4,000. And if I put 4,000 in for x, I get 2,000 for y. So there is the points that we want to test with our objective function. 0, 0, 4,000, 2,000, 6,000, 0. That's this point right here. And 0, 4,000. Those are the vertices of the region that is created by the intersection of all the points that satisfy the constraints. Okay, so you could picture plugging these points into the objective function, but I'm going to go to Desmos and show you what it looks like. So there is the region right here that we talked about. There are the 4 vertices, and I made up this function. The number of victims, depending on x and y, is 6x plus 10y. I put in those 4 ordered pairs, 0, 0. Of course, there'd be 0 victims that were aided. 6,000, 0 would be 36,000. 0, 4,000, 40,000. And 4,000, 2,000 gives me 44,000. So it is indeed the 4,000, 2,000 combination. 4,000 medical kits and 2,000 containers of water that will aid the most people. Down here, I've turned the objective function into slope-intercept form so you can see the objective function moving up through the region right there. And when it hits the point 6,000, you can see that C is 36,000. That's the number of victims. When I go through the point 4,000, C is 40,000. But when I finally get to this vertex, C is 44,000. So that's your answer. 4,000, 2,000 will aid the most victims, and the most victims that can be aided are 44,000. Okay, so I'm going to end the video. Hope you understood that, and I'll send it along.